Okay, good morning everybody. Welcome along to our My Electric Avenue webinar. My name is Becky Lees. I'm the Assistant Project Manager for the My Electric Avenue project. This session is 30 minutes long and we've got 10 minutes at the end for questions and answers. You'll see a couple of icons at the top of your page at the moment. One of these is a speech bubble. This is the chat function, so feel free to write any questions you have as we go along through the presentation. My colleague Tim Butler, the My Electric Avenue project manager, will be answering questions at the end of the session, so he'll be looking through that speech bubble chat function to see what questions you might have. The session's been recorded, so the slides and presentations will be recorded and uploaded to our website for anyone who might be interested to learn and see them but hasn't managed to make the session today. Okay, so today I'm going to introduce you to EA technology. I'm going to talk to you a little bit about home energy usage today. I'm then going to introduce you to the My Electric Avenue project, talk a little bit about our early results, and then how the trial itself, the project, has had an impact on EV uptake compared to things like test drives, and then share a little bit about the learning we've got from the recruitment process. Okay, so EA Technology, who are we? Well, we're an engineering and power asset consultancy. We provide product solutions and different consultancy services to help networks become more cost-effective and reliable both in the UK and abroad. For example, things like power engineering, power quality, network design and protection, specialist electrical engineering services for things like substation and overhead lines assessments and partial discharge assessments. We've got our own Power Skills Training Centre with courses tailored to provide skills for different companies. And we also offer a range of different products, so our UltraChev range, which detects and monitors partial discharge, which won the Queen's Award a few years ago, and our software products, things like WinDebut and Crater. Based on our expertise, we've been asked before to work on a few low carbon network fund projects. These are projects looking at issues affecting all UK DNOs, and they're partially or fully funded by Ofgem's fund. And typically these are led by UK DNOs, so these are things like the Customer-Led Network Revolution and the new Thames Valley Vision project. Now we're leading on our own groundbreaking LCNF project, and that's of course My Electric Avenue. So imagine that this is your house at home. You might have electric hob, an oven, you probably have an electric shower, clothes dryer, kettle, a hairdryer perhaps. So basically you have several different electrical appliances in your house, and altogether the load that they create adds up to a certain level of demand that's pulling from your house. Your cutout fuse is good for 20 to 30 kilowatts, so the idea is that all your appliances don't go over 30 kilowatts to make sure that your house can support that load. I just want to draw your attention to the kettle actually. This draws a relatively small load compared to the others, 3.5 kilowatts, compared to things like an electric shower, which is 8.5. I'll explain later on why this is important. So imagine you start charging an EV at your home as well as using all those other appliances I mentioned earlier. Well, some EVs create bigger loads than others. Some charge at 2.5 kilowatts, like the Nissan Leaf, and others charge at 7 kilowatts, like the Tesla, I believe. It also depends on what kind of charger or charging cable you have, but essentially the time it takes to charge depends on the level of discharge. EVs typically charge for a couple of hours minimum, as you can see here on the graph. So whilst it's only a similar load to a kettle, generally speaking, you don't boil a kettle constantly for 2 or more hours. This type of load is constant. You can see from the graph it goes up and it stays up, it doesn't vary at all until the car's finished charging, in which case it tails off. So it's different to other appliances in your home. And even though it's not necessarily a huge load, it's enough and it's consistent. And if you add this to your normal home energy profile, along with all the other appliances at the particular tea time peak, it can make things tricky for the network. Okay, so let's introduce you now to My Electric Avenue, what we're trying to do. My Electric Avenue is a £9 million project that is looking to understand the potential impact that EV charging might have on low voltage electricity networks and to trial a new technology called Esprit to reduce that impact. And the project is funded with in-kind contributions from EA Technology, SSEPD, Fleet Drive Electric, Zero Carbon Futures and Nissan to the tune of about 5 million, as well as Ofgem's Low Carbon Network Fund, which has awarded the project 4.5 million. So I mentioned Esprit, but what is it? When I talk about Esprit, I mean two things. A monitor controller box that sits at the local substation and it monitors the electricity cables and imposes a certain threshold. The monitor controller then sends communications or messages down the electricity cables to properties if that phase current, if the loading goes over that threshold. The second item is the Intelligent Control Box, or ICB. This is installed alongside the charging point at the customer's premises. This receives the messages from the monitor controller, and when it's instructed, it controls the charging points. So, imagine a scenario where the load on a particular network goes over its limits. The monitor controller would react, send a message to the ICB, Intelligent Control Box, and the ICB would tell the charging point to stop charging. So what does that mean? Well, by monitoring and controlling the charging points, EV charging can be shifted to off-peak times of day, in electrical terms of course. For example, this is around late at night or in the early hours of the morning when the electricity cable has capacity to support that load, that extra load, but without placing the network under undue stress. So to trial a new technology which manages EV charging, you need people to test this technology, and this means customers, or more specifically, EV drivers. So we recruited customers to 2 trials. The first trial is the technical trials, where we needed a minimum of 100 people in very, very local areas, basically neighbours on the same street, to test a new technology which would monitor and control their EV charging in a home or workplace. They had to be in specific geographic areas. So we were working with distribution network operators. These are the companies who own and manage the electricity infrastructure. And we had to be using the infrastructure in their licensed areas, which were in the northeast or in the south. The social trials was the second group we had going, and that was a comparison or a control group. So these customers were providing EV charging and driving behaviour, but they weren't, crucially, they weren't testing the technology, so they were a comparison to normal behaviour. Okay, so who do we have on the trials? Well, here you can see on the map we've got an indication of where our technical trial clusters are located. So remember again, these are participants who have signed up as a group to have their EV charging controlled, and are shown here by the blue circles on the map. And each little blue circle represents a cluster, a group of neighbours who've all clubbed together to take part. You can also see where the social trial participants are located. These are having their charging and driving behaviour recorded, but they're not having their charging controlled like the technical trial customers or participants are. They're shown here by the light green diamond shapes on the map. Okay, so the male and female split is roughly about even, with a slight majority of men taking part in the technical trials and a slightly larger majority shown in the social trials, as you can see in the pie charts. Across both trials, roughly 40% are in their 40s, although the age range does span across from 30s up to retirement age, which is quite interesting. And a typical 2.4 family unit is common. Almost half of the technical trials are in a family of 4, which could suggest that perhaps the EV that we've offered as part of the trials over the Nissan Leaf is useful for a family runaround. So now we'll take a look at some of the early results from the research that De Montfort University have conducted with trial participants on behalf of the My Electric Avenue project. Most of you will have heard a little bit about range anxiety and the potential this has for dictating driving style or putting people off trying EVs in the first place. So following delivery vehicles and the start of the trials, we asked participants how easy are EVs to live with, as well as how many miles they tend to drive, and then map that against each other. Perhaps unsurprisingly, those who reported that EVs are easy to live with fit the typical pattern and generally do fewer long distance journeys, so here we're talking between 50 and 70 miles, and actually spend most of their time driving at shorter distances, things like 10 miles or less. You know, up to 75% of their journeys are 10 miles or less. That's quite something. We also asked both technical and social participants where they tended to charge most often, and found that the majority of charging is actually at home, 66%. Few tend to regularly charge at public or charging points. In fact, only about a fifth, 18% here. Some of our trial participants have actually shared with us their experiences of the public charging points that they've tried out over the course of the trial. And the general feedback so far is that they vary in reliability, but this is of course only anecdotal feedback. But it's interesting to note amidst the most recent reports being published about the roadmaps for EV charging infrastructure. The EVs on our trials, of course, tend to be charged throughout the day, with two peaks occurring around 8 o'clock in the morning and 6 o'clock at night. So this supports a scenario which we're working to mitigate when a number of residents come home from work and they all plug in their EVs at the same time, right on top of the tea time peak. That's when everyone comes home and starts cooking tea, starts using all their appliances at home at the same time and at the same time as their neighbours. And this tends to create a situation which can be challenging for the electricity networks. However, a significant number of EVs are tending to connect at 11:30 at night on our trials, possibly due to time of use tariffs. So charging at night can be cheaper depending on the electricity tariff, which might be having an impact here. Based on the data from our trials, it appears as though participants go through a particular learning curve when it comes to charging their EV. University of Manchester found it takes drivers 1 week to settle into a routine for charging, and that after this 1 week, most EV users or the trial participants are likely to adopt a repetitive charging behaviour and tending to plug their vehicles in less frequently every day, maybe because they've become more confident or perhaps get a better grip of what the car is capable of and its range. The graph shows the charging patterns that participants settle into once they get over this learning period. It shows the state of charge, which means how full the battery is when it's plugged in. And the x-axis shows 0 to 12 because there are 12 segments to a Nissan Leaf battery. I'll be honest, I'm not entirely sure why. And on the y-axis is probability of plugging in. And it shows there's no significant charging behaviour differences across the season. So we've got winter in red, spring in blue, got summer in green and autumn in black. And largely you can see that the pattern is broadly similar. EVs are charged mostly when their state of charge is between 3 and 8 units, so the battery is over half full, but participants still charge anyway. And a number are still connecting or plugging in when their state of charge or battery is higher than 10 units, so the battery is almost full. But again, they're still charging. So is this habit or is it range anxiety? So what we've done on the project is conduct a number of interviews and focus groups, qualitative research, conducted by De Montfort University, which has explored this in a little more detail to understand the reasons behind this behaviour and what's driving it. And their report will be published later this year. Okay, so this now draws out some of the charging behaviour of just the technical trial participants. And the reason why they're particularly interesting is because they've opted for controlled charging in return for a reduced price lease, that's £100 a month. The participants were given online surveys after the delivery of their EV, but crucially before controlled charging was activated, and then again once the controlled charging was in place and working. So this draws out the effect of controlled charging on charging patterns. So in the graph here you can see we asked participants when they tended to recharge their EV. The blue bars show their charging patterns before control was activated, and the red bars show their responses after control was activated. Controlled charging has increased participants' tendency to charge as soon as they get home, rather than waiting until the battery is getting low. Presumably because they can't be sure if their charge at other times might be interrupted by Esprit and want to make sure they have enough charge for the next journey. This, to us, appears to be habits adapted as a result, as a direct result of demand-side response control of EV charging. We also asked participants how they typically charge their EV. And before control charging was brought in, 82% charged their EV to full. A very small proportion charged it for a set time, which is actually what's instructed by the manual, at least for the Nissan Leaf. I'm not quite sure for other manufacturers. Again, a relatively small proportion charged it for as long as possible, and others had no regular pattern. After control charging was brought in, there was actually very little difference in terms of how long they charged it for. So a similar proportion still charged it to full, and there was a very small increase in those charging it to a set time. So the real difference from control charging that we can see from this data is that the habits of when people plug in terms of their habits of when they actually charge, those have changed. Yet once it's plugged in, those sorts of habits are either leaving it to charge until it's fully charged, or for as long as possible, or for a set time. That tends to stay the same. So if demand-side response became mandatory, how much of an impact would it have on customers? Well, to understand this, we need to understand customers' flexibility when it comes to charging at home. On the left-hand side of the pie chart, you can see that most technical trial participants have their car parked at home for more than 10 hours. That's 80% have their car parked at home for 10 hours. So it is feasible to shift charging to later in the evening. This is a reasonable solution to connect with network constraints to EV uptake, as long, of course, as customers accept the limited availability of charge during those peak hours, the tea time peak I was telling you about before. Now, bearing in mind that the technical trial participants have controlled charging, we asked them, does their EV charge sufficiently in the time available? And looking at the right-hand side, the bar chart, the majority of these participants actually agree, even though they're being controlled. So 52%, if you're adding up those who say they agree and strongly agree, said that their EV charges sufficiently in the time that they've got. A third aren't entirely sure, or have opted to say neither, but only 16% disagree. And whilst in the minority, perhaps it's because these participants have limitations on their flexibility. So let's look at some of our technical trial participants' experiences of controlled charging to date. So let's see, how much has it impacted customers? Well, between the 1st of January and the 16th of June, the Chinham cluster technical trial participants were switched 871 times while they were trying to charge. The South Shields cluster, or South Shields 1 cluster, because we have two in the same area, was switched 825 times. And our Your Homes Newcastle cluster, that's our only workplace cluster, was switched 650 times. Across all the clusters, technical trial clusters, the total time customers are being curtailed during charging is 68,371 minutes in total, which equates to 1,139 hours or 47 days. A solution like this, whether it's Esprit or it's control via a charging point, could facilitate a quicker uptake of EVs in the years to come. But what effect could it have on sales or leasing of EVs and, crucially, customers' perceptions of EVs themselves? Well, here we can see this is technically how much interruption has been caused by Esprit on our trials. But what effect has it had on customers' views of EVs as a whole? Okay, so here we can see in the pie charts our technical trial and social trial perceptions of EVs, specifically how easy it is to live with them. Okay, bear in mind again, remember that the technical trial participants had their charging controlled in a way that the social trial participants haven't, and this might have a bearing on their perceptions of EVs as a whole. This is what we might expect. However, looking across at the two pie charts, it doesn't seem to have made that much of a difference in their views. So looking at the left-hand side, technical trial responses, roughly half agree that EVs are easy to live with, and a quarter strongly agree that EVs are easy to live with. Only a minority, around between 4 and 7%, disagree. I must note that these results are from a fairly small sample size, so small differences shouldn't be read with too much significance, but it's a really positive picture for electric vehicle acceptance and, crucially, for technology which controls charging. This is significant not just for Esprit, but for any smart technology which makes choices about home energy usage. So I've just taken you through some of the early results, the interim results from the trials and participants, but we want to hear what you think too. So please do go to our survey. This is a link that was provided in your invitation and here as well, and tell us about your views of EV uptake and impact of Esprit. Remember this controlled charging on things like chargers and EVs. In this section, I'd like to talk a little bit about the impact of a trial like this on EV uptake. "41% of participants, these are both technical and social participants, have told us they intend to lease an EV after the trial ends, and 17% have said they're intending to buy. Now, considering the majority of these participants may not have even considered an EV before participating in the trial, I think this speaks volumes about the impact that trials like My Electric Avenue can have on the uptake of EVs, or potentially any other low-carbon technology. I don't have the statistics to hand, but it'd be interesting to compare these with the percentage of customers who say they're going to lease or buy after test drives. I think that'd be really interesting to see. There's been a fair bit published recently on roadmaps for EV charging infrastructure, so we thought it might be interesting to see the impact of public charging on our participants' intentions to lease or buy after the trial ends. Now, only 19%, that's 37 people, reported that it was easy to find somewhere to charge away from home, which suggests to us that perhaps the infrastructure is lagging behind a little bit. But is it needed for EV uptake? Well, the majority have said that they struggle to find places to charge, around 117 people in fact. But despite this, people are still willing to lease or buy, perhaps because they can charge at home. Of those 117 people who said that they struggle to find somewhere to charge away from home, 43 are still intending to lease after the trial, and 12% are still intending to buy. So perhaps it's not such a deterrent after all. I must note again that this data is, however, just from our trials. That's 220 people in total. And I'm aware of a few participants who would strongly disagree with me. Minority have and continue to send me very lengthy emails regarding their proposed improvements to charging infrastructure. So ultimately, a larger survey would be needed to provide a wider population view, but it's a great indication. There are elements of how we recruited customers for the trials which could feasibly be adapted to business as usual for leasing and selling EVs. So the next couple of slides, I'm going to talk a little bit about some of the approaches we took and how they might be used elsewhere. The project chose to engage on a local rather than a national level, mainly because of things like recruitment timescales and project deadlines, and also the restrictions we had on network areas. However, this strategy was fundamental to the success of the recruitment drive. Engaging with local community groups initially and then later individuals themselves, or as we call them, cluster champions, who provide a local face and a name and represent the project on the ground. These champions were, and still are to a large extent, absolutely essential for engagement and building trust amongst customers who had perhaps considered trying an EV but hadn't yet taken any active steps to investigate them any further. Remember, of course, that the technical trials had to be dictated at a need for people to submit an application, but as a group. There had to be at least 10 people, a minimum of 10 people to begin with, or more, to actually go forward with their application. So some of these neighbours will have had a little bit of peer pressure applied to them by their other neighbours who wanted to take part, so they might not even have considered an EV. So in summary, our approach was to provide some support to the local cluster champion and obviously a level of hand-holding, while they go out and recruit other people. And then once we have enough people interested, then hold things like test drive events. And you can see some of the videos from those test drive events on our website. The approach we took was hugely successful, and in the space of just 8 months, the project had 19,000 visitors to the website, about just over 2,000 registered interest, 246 cluster champions, and 70 clusters, and now we have 220 participants. So most of this was a little bit of a surprise. It was mainly unanticipated by the project. We didn't expect such a huge response, but the approach worked, and the offer was really, really good, and the timing was even better. I think if there's ever a business case for this type of approach, this case study might be very useful. So the big question is, how can this learning be used across sectors? The customer engagement approach that we took on My Electric Avenue could be a potential opportunity for both charging point providers and EV manufacturers if it's managed carefully. So there is a potential to sponsor, for dealerships perhaps, to sponsor local green groups and organisations, to tap into these networks and use these as a springboard to get in touch with more people and to just reach more people and sell more EVs. We've proven that customers respond extremely well to local contacts, and trust in a neighbour or similar is far more powerful than recognition of a brand or company. So it really is worth putting the time into these networks, these local community groups, green groups, because they are keen and they are useful. And we've shown already in a few slides earlier that many participants have said they're planning to lease or buy after trials. Is it possible, I wanted to provide a longer test drive in the business as usual case for leasing? I know that this is done for fleet vehicles and it may be too costly for individuals, but I think based on the learning we've got from these trials, it's certainly worth considering. Finally, quite often we get tweets and emails and things rating the project, the car, and even the charging infrastructure. And even though the latter two are largely outside of our control, they still provide opportunities. And whilst we were recruiting, we engaged with certain EV bloggers. So these are people who upload videos of themselves driving in their, well, in this case, a Nissan Leaf, and giving a review of the car or the charging infrastructure for free. And these contacts are invaluable for people who are yet to make the leap from traditional petrol or diesel to electric, because they represent a non-branded and non-corporate marketing tool for engaging with customers. And what's amazing is that they're so passionate about their EV that it doesn't actually involve a huge amount of effort to get these people on side. They're so keen that actually it's a free resource for spreading the message in terms of your Nissan Leaf in this case, or other EV. And it can be incredibly useful to get people to think about switching to electric from petrol or diesel who might not have thought of it before. So what does this mean for you? Well, what ties together our approach to recruitment is largely that it's proactive and strategic, and I'm well aware that some of the things I propose might not always be possible or affordable, but it's well worth the effort if those possibilities are there. So in terms of enabling a transition to a low carbon future, particularly for promoting EVs, I would recommend you consider the local route. So how can local communities help promote an initiative or a product or a car, for example? The power of communities varies geographically, we know that, but it shouldn't be underestimated. Neither can the effect of keeping up with the Joneses or sheer passion and enthusiasm from just one person. Having champions, as we term them, can have a massive impact on how something is perceived in the local area. In our case, it was the project and the Nissan Leaf, and the champions were exactly what we needed to boost interest. And whilst it might seem obvious, networking with small organisations or local community groups can be just as good as networking with larger companies. If you can tap into their networks, this can provide a real benefit to promotional campaigns. So that's everything from me. Thank you very much for listening. I'm going to pass over now to my colleague Tim Butler. He's the project manager for My Electric Avenue, and he's going to be answering some of your questions.